So in this video, I'm going to show how to do content search. The idea here is to search inside the video to find uh, what is on the video, what are the objects are on the video. We can either do this on a real time, meaning somebody is taking videos from a phone or whatever, and in real time the data is sent over the application and we'll get everything that is on the video. And let's say, for instance, we can make also annotation, this kind of thing. And actually this technology is used for some worldwide company car that want to create assistance for a driver, for any driver. In this particular case, this is just a prototype, and to show how easy and cheap this is, easy and cheap this is to do this kind of usage. So let's go back to this approach. So the idea here is I have a search engine, a small search engine that is available. We can download it. I mean, we can even write it yourself. This is something that this is quite easy to do. This front end is written in PHP, HTML5, whatever, and there is a backend plus a database with object storage and the application here. The application here, we have a service, Watson Cloud, IBM Cloud Watson service here. So this is a per usage service, meaning every time you upload something to do analysis, you will get a fee on it. But as you may see on the website, this is ridiculous, and you have 250 analyses per day free, which is quite nice. You can see it better. And then I have my videos here. You can either have a pack of video or something which is in real time, which is on the air, depending on what you want to do. So this is it. If now I go on my on my Bluemix portal, my IBM Bluemix portal, I see all the services I have. So this is my front end. I have my back end on which is linked with it for this purpose of this presentation. I didn't take time to do a backend. Anyway, this is just a presentation. I have a MySQL DB, and I have some services which is Watson Visual Recognition. As I have also created Cloud Object Storage services. So Cloud Object Storage is S3 compatible or Swift, API compatible. So this is quite easy to either do Swift or S3 depending on what you want to do. In this particular case, we'll be using S3. IBM Cloud Object Storage S3 API. Why S3? Because of the metadata we can use with it. Okay, so here is my search engine. Okay, here are my videos. So the video you can find here, this is just a drag and drop, and this bucket on Cloud Object Storage will be the bucket that I'm going to parse to do the analysis. Okay, so let's start then. This small script will parse the bucket and then will parse the bucket, and then the application will be given a new URL, and that URL will be analyzed and it will process all the visual recognition and the content search. So now let's start. So it will analyze the 3 video here, and as you can see, it started the video, as you can see here. So it takes some frames inside the video, does the analysis, and just go back here. every time analysis is done, a frame is a picture. So this is the name of the frame. In this one is it's the first frame, the name of the video, and the metadata it has on it. And it has also every frame has a unique hash, which is quite cool because let's say if you want to do some deduplication based on file or based on the structure of the data, this is cool to have. We've missed the second video, which is scuba, some people that are diving, and we can also have this, which is quite nice, the timestamp. The timestamp is the timestamp of the frame. If I go back, oh, we have a lot of done. Okay, it's continuing. It says okay, and this one will have more metadata. Okay, takes much time on this one because this one is a little bit bigger. Picture is a little bit bigger. Okay. Okay, and the last one, this is the last video. Going back. Okay. In this video, I'm also syncing two buckets, the temporary one plus let's say the archival one. This is optional. This is not something you have to do, depending on what you want to do. Let's say if you want to store every frame, and on every frame you want to create a picture, and on every picture you want to add the metadata on it, this is something that you should do, you should consider to do. But if you just want to sorry, to analyze the video itself, and you do not care about the frames and the picture, etc., then you can just keep the database itself and use that database to go directly to the video and get rid of all the frames and picture, etc. So I will just wait for the data. I will just go there to check if, let's say, do a horse. I'm finding nothing, which is normal. So I'm going back. Sorry, here. I'll check while it is finished. Just for while waiting the analysis to be finished, I will go here and we'll go back to the sorry, again, the framework. The idea here is when everything of my analysis is done, I will just be clicking on some button. Let's say on this one, I will be clicking on this link here, sample1.mp3, and I will get to directly to that video. Or if I click here on frame 100, I will the idea is to be taken directly where a horse is seen. I mean, this picture is seen. And finally, if I want to download the video, I will download the picture. I'll just click on this link. So I'll go back now on my search engine and I'll do a horse again. So now it's taking a bit of time here. As you may see, it found a horse on frame 100, and if I click here, I will get this. Now if I click here, I missed. I'm just clicking again. Okay, it opens. It actually opened at time 3, at the second 3, where at the timestamp 3 seconds, where the horse has been seen. And finally, as you may see down the screen, I can also download a picture, which is also stored in a bucket in Cloud Object Storage. And if I click on it, I found it. And the idea here, if I download, I mean, if I using the S3 API to ask for details on this resources, I will get all the metadata directly by using a small API call. Okay, so this is working. Now, if I do a dog search, let's see what I'm going to have. Okay, now I have more pictures in this one. Okay, it keeps clicking. No, it's done. So here are all the picture I got. Oh, I got it 2 times, not normal anyway. So I have my metadata here, and same here. If I do this, I go directly to Segondia, which is not good. I'll go type to scuba diving. Okay, get something. Okay, 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 okay. Now, if I go here, let's say, I should go to timestamp 7 seconds. Okay. My Wi-Fi is really bad, but still it goes to 7 seconds directly. So which is good because now we can do content search based on what I got here on my videos. And if I do this, for instance, person, I will get those pictures where a person are seen. Okay. Okay, then this is it. We can also go back to the picture itself, and it is stored in another bucket. I've stored here this one, so we can have all the picture that have been analyzed. And this ID, the ID behind this demo here is not to show um, the precision of it, because there is a lot of room here for improvement, of course. In this case, for performance consideration and for Wi-Fi consumption consideration, I've just taken a couple of frame, but actually we can also do something more interesting. For instance, every 10% of difference between frames, I'm taking this frame and sending for analysis to Watson and get back that result. And what we can also do is to log, and I'm sending what Watson has seen to check how we can work this, and I can download this log, and this log can be used afterwards, sorry, to be sent to a cluster ELK, Elasticsearch, or any Splunk or whatever, and then we can do we can search using those tools. If I go here and I have it, okay, so here is all the metadata that has been seen by my by Watson, and it is all written in this log file. And as I said before, here's the picture. I can, let's see if I copy and paste here. Okay, I'm going back here with this. Okay, so this is it. I hope this video was enough to show you how the Watson capabilities with object storage and cloud, IBM Cloud, everything you can do with it. So hope you enjoyed the video. Thank you.